Hello, I imagine that you are taking physics. And if you are in physics, then you probably have to look at and use the kinematic equations. So these are the 4 kinematic equations, and in this video I'm going to tell you everything you need to know about these 4 equations and where they come from, and I'm not even going to use calculus. I'm going to derive these without calculus. Okay, so what are we talking about here? The kinematic equations, and these are the one-dimensional kinematic equations. The kinematic equations are ways to describe mathematically the motion of a car that moves with a constant acceleration. So the acceleration is constant. That's very important. Okay. If the acceleration is not constant, most of these don't work. And if you're in an introductory physics course, most of the things you're going to see have constant acceleration, but I guarantee you not all of them. Okay. So that's an important thing to remember. You can only use these with constant acceleration. Now let me start off with the very, very fundamental definitions that we have here. And these are in one dimension. First is the definition of velocity. This says the average velocity is defined as the change in position, where this position would be where you are on a number line, divided by the change in time. So here's the other, I'm going to have conventions over here. And the first one is delta. So when you see this triangle delta, this literally means change in. So delta x is equal to x2 minus x1, or x at the beginning minus x at the end. Delta t is going to be t2 minus t1, or t final minus t initial. We're going to talk about that too. Okay, so that's what delta means. So the average velocity in one dimension is the change in x divided by the change in time. Okay, you may say rate equals distance over time. This I'm going to put in a red circle because I see this a lot. Don't do that. Rate is not distance over time. Okay, there's a lot of problems with that. If you use this, you may get the right answer in some situations, but a lot of times you won't get the right answer. This is better. Okay, so that's the first definition. The next is the definition of the acceleration. Now, I don't have to put average acceleration here because I already said acceleration is constant. So acceleration is acceleration. And this tells you how fast your velocity changes. The average velocity tells you how your position changes with time. The acceleration tells you how your velocity changes with time. So it's the change in velocity divided by the change in time. Now, there is one other definition of average velocity, V average, and that's V1 plus V2 over 2, just like an average. If I want to find the average velocity, I can take the initial velocity, the final velocity, and add them together, divide by 2. That would be average. This only works with constant acceleration. Okay, let me put down my other conventions. So you may see here I'm using this equation right here tells you what the final x position is, and that's the initial x position. So you may use something like 1 and 2 to represent initial and final. So if I draw over here some options, initial, final. What could I use? What subscripts could I use? I use 1 and 2. Okay, you may have a book that uses I and F. It's the same thing, right? If I say XF equals XI, it's the same thing. I could write it up here. X final equals X initial plus V initial plus V final over 2, ran out of room, over delta t. So that's the first one. The other thing that you could use is the initial is 0 and the final is just blank. So x is the final x, and x0 would be the initial x. Those are the ones that you're going to see the most often. Those 3. Okay, one other thing, a lot of times delta t will be replaced with t. This is what you will see if t initial t1 is equal to 0, then delta t is the final t, and they just call it t. Okay, I'm going to use delta t because it's just a little more formal and more correct. So up here I have delta t, over here I have delta t. So that's what I'm going to use. Those are the conventions I'm going to use. Okay, let's jump into it and go ahead and derive this first equation. Okay, so this first equation uses the definition of average velocity. V average is delta x over delta t. Now, I can also use the other definition of average velocity, that's a t, which is v1 plus v2 over 2. Now let's go ahead and multiply both sides by delta t. So if I multiply both sides by delta t, parentheses, these delta t's cancel, and I get delta x equals v1 plus v2 over 2 times delta t. Now I'm going to replace delta x with x2 minus x1, so I get x2 minus x1 equals v1 plus v2 over 2, times delta t. Finally, I'm going to add x1 to both sides of the equation, and I get x2 equals x1 plus v1 plus v2 over 2 delta t. So this tells you the final position of an object if you know the time and the starting and ending velocities along with the starting position. Okay, so if you don't know the actual acceleration, you can use this. But you need to know the time and the beginning and ending velocities. Okay, let's do the next one. Let's start with the definition of acceleration. A is delta v over delta t. So delta v is just the final velocity minus the initial velocity divided by the change in time. Now I can multiply both sides by delta t, and I get v2 minus v1 equals a delta t. Now I can add v1 to both sides. v2 equals v1 plus a delta t. This tells you the final velocity for an object if you know the acceleration and you know the time and the initial velocity. Okay, it's really just, all I did was just rewrite the definition of acceleration. Up here I actually used two definitions of average velocity to get that. So these are the two easiest kinematic equations, but let's go ahead and do the other one. So let me start with the definition of the average velocity. Again, v average equals delta x over delta t. And I'm going to go ahead and put in x2 minus x1 over delta t is equal to the v average. Okay, I'll write it right here. Now I'm going to multiply both sides by delta t, and I get x2 minus x1 equals v average delta t. Now I'm going to add x1 to both sides, and I get x2 equals x1 plus v average delta t. Okay, the next thing I'm going to do is to use my definition of average velocity. V average is v1 plus v2 over 2, and I'm going to put that in right there. So this gives me x2 equals x1 plus v1 plus v2 over 2 times delta t. Now, this isn't completely unuseful. It's actually what I already have up here, but I rederived it. I wasn't thinking. So what if I don't want v2? Okay, if I don't want v2, I can actually use this equation for v2. So I can put this thing in for v2. So let's do that. If I do that, I get x2 equals x1 plus v1 plus, now v2 I'm going to put as v1 plus a delta t, all of that over 2 times delta t. Now I'm going to, here I have v1, and v1 is 2v1. So if I multiply this out, I get x2 equals x1 plus v1 plus v2 is 2v1 over 2. I got to divide that, and I have the delta t. Then I have plus 1/2 a delta t, and I have 2 delta t, so I have delta t squared. And so this is just equal to x1 plus v1 delta t, because the 2's cancel, plus 1/2 a delta t squared. That's it. That's your third kinematic equation. So you need to use this one. This one actually used the most, I think. If you know the acceleration, the starting velocity, and the time, you can find the final position based on the initial position. Okay, we have one more kinematic equation to derive. So let's start with a clean sheet of paper. So I'm going to start with, I'm going to go back to my other definition. I already derived this twice. So I have x2 equals x1 plus v average delta t. Well, I already had that, right? And that was equal to x1 plus v1 plus v2 over 2 delta t. Okay, so I want to eliminate the delta t. So what if I take this equation, v2 equals v1 plus a delta t. I'm going to subtract v1 from both sides. I get v2 minus v1 equals a delta t. Now I'm going to divide both sides by a, and I get delta t equals v2 minus v1 over a. Now I can take this and put it in up there. So now I have, I'm going to go ahead and subtract x1 from both sides. So I get x2 minus x1, right? So that essentially moves that over here, equals, now I have v1 plus v2 over 2. And now instead of delta t, I'm going to put in this, which is v2 minus v1 over a. So on the bottom here, these are multiplied together. I have 2a. So I'm going to multiply this side by 2a. I have to multiply this side by 2a. So now I have 2a x2 minus x1 equals, I'm going to just switch the order here, v2 plus v1 times v2 minus v1. Now I can FOIL this out, right? The first inside, outside, last. So I have v2 times v2 is going to be v2 squared. Now I have v2 times negative v1 is negative v1 v2. Then I have v1 times v2, which is going to be plus v1 v2. And then I have v1 times negative v1 is negative v1 squared. And these two interior terms cancel. So this is v2 squared minus v1 squared. Now I'm going to add v1 squared to both sides, and I get v2 squared equals v1 squared plus 2a x2 minus x1. So this is just, I add this to both sides, and here's the other side. So I just add v1 squared to both sides, and I get this stuff. And there is your third kinematic equation. So what's really important about this one is that it has no time. Right? There's no time in that equation. So if you know, I know where it starts, I know where it ends up, or I'm trying to find that, and I know the initial and final velocities, but I know the acceleration, or I know where it starts and ends, and I know the starting and ending velocity, I can find the acceleration. So the important thing to remember is, why is that 2 there, right? Why is that a half and the other one? It has to do with, both of those come from the definition of average velocity. So that's why there's a 2, because you're averaging. But there you go. That's your kinematic equation. Now, let me give you one bonus kinematic equation, because let's say you want to deal with this in 3 dimensions. In 3 dimensions, I could say as a vector, and if you don't like vectors yet, then just close your ears and go la 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 la. Don't listen. So the definition of average velocity is v average as a vector is delta r, where r is the vector position over delta t, and the acceleration is the change in vector velocity over the change in time. If you do that, you do get something like this. R2 vector equals R1 vector plus V1 vector, delta t, plus 1/2 a vector delta t squared. So this is a vector kinematic equation. And so in this case, R has x, y, and z components in there. So this is actually like 3 kinematic equations all in one time. If you don't like that and you haven't gotten to that yet, just click next or whatever and just go out of this video. You don't need that, but I just want to show you that same thing works. The same derivation works if you use everything as a vector. So there you go. There's your kinematic equations. I hope you enjoyed that, and hopefully you find it useful. I'll talk to you later.